Afternoon or good evening, depending on where you are in the world, and welcome to today's Information Week webinar, Maximizing Database Performance to Improve Customer Experience, sponsored by Dell Technologies and broadcast by Informa. I'm Peggy Bresnick-Kendler, and I'm with Information Week. I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the Resources widget. Toward the end of our webinar, we'll ask you to complete our survey. It's found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And finally, if you experience any technical problems, please click the Help widget found at the bottom of your screen, or simply type your issue into the Q&A area, and we will be glad to offer one-on-one assistance. Now on to our presentation, Maximizing Database Performance to Improve Customer Experience. Discussing today's topic is Doug Kim. Doug is a distinguished engineer in the Office of the CTO in the Server and Infrastructure Solutions Group at Dell EMC, where he drives technology and strategy for accelerators and accelerated workloads. He brings more than 25 years of FPGA, ASIC development knowledge, which helps drive the advancement of emerging technologies and new industry standards such as Gen Z and CXL. He has a BS in Electrical and Computer Engineering from the University of Texas at Austin, and he has 13 patents with Dell EMC. Also joining us today is Prasanna Sundarajan, CEO of rENIAC. Prasanna is an experienced architect and innovator with a track record of taking new and early-stage technology concepts from inception to production. He has 30 issued patents in the areas of computing and cache architectures, security, fault tolerance, and reliability, and design tools, and his extensive technology experience in multi-cores, GPU, and FPGA-based systems. After spending nearly 13 years at Xilinx at a variety of roles, he co-founded rENIAC to bring drop-in data acceleration to customers that require ultra-low latency for large-scale data-centric applications like product catalogs, media retrieval, fraud prevention, and risk analysis. Doug, why don't you kick things off today?
Thank you, Peggy, for the kind introduction and for giving us the opportunity to speak to your audience today. My name is Doug Kim. I'm an engineering technologist at Dell EMC. I specialize in FPGAs and workload acceleration. I spent most of my career prior to Dell EMC working with ASICs and FPGAs at various startup companies, leading design teams for design as well as prototyping and emulation. At Dell, I'm actively involved in FPGA-based proof of concept designs. As Peggy mentioned, I also drive accelerator strategy for PowerEdge. And I work very closely with ISV partners such as rENIAC to kind of help drive the adoption of FPGA accelerators and to ultimately put together complete solutions for our customers. Today, Prasanna and I will be discussing several ways to maximize database performance, leveraging PowerEdge servers, and some key technologies from our partners. So data is booming. Data is growing exponentially and continues to put a massive burden on our existing infrastructure. Today, nearly 5 billion consumers interact with data on a regular basis. That's about 2/3 of the world's population. And that number is projected to grow by another billion in the next several years. For each of these consumers, think about how many devices that each person has and uses on a regular basis that continues to produce and consume data. Think about your laptops, your cell phones, your cars, virtual assistants, TVs, wearable devices, and so on. The list goes on, and it continues to grow. By 2025, there will be over 150 billion devices that will be connected across the globe and creating data in real time. By then, the amount of generated data is projected to surpass 175 zettabytes. That's 175 followed by 21 zeros, or a trillion gigabytes of data. And that's just in the next 5 years. And that number obviously is going to continue to grow as time moves on. So needless to say, this explosion in data is putting a tremendous amount of strain on our databases. Most databases were never designed to handle this massive growth in data. And as data grows and databases scale out, it takes longer and longer for servers to process read and write requests. Processing time goes up just as we're moving into a time where the world is getting very used to instant gratification and response times in the milliseconds. In addition to delays in processing time, read latency can also suffer, ultimately degrading performance as these databases grow. So what's been done? To compensate, businesses have already swapped out their relational databases for open source NoSQL databases like Apache Cassandra. Even though they were designed for higher data volumes, these advanced databases are also experiencing bottlenecks, and they simply can't keep up with the demand. Because of this, many enterprises have added more database nodes, but adding more servers to fix the problem can get costly, doesn't necessarily address latency and performance issues that are caused by scaling. Database teams, these engineering teams, are also spending a lot more time tuning performance, which in turn means companies have to hire more staff, which can also be very costly. Ultimately, more nodes, faster servers, more personnel, database optimizations, they're all just stopgap measures at best. No matter how much money organizations throw at these sort of temporary solutions, data is going to continue to grow and eventually exceed their ability to keep up. So what can we do to eliminate some of these bottlenecks and deliver ultimate performance for enterprise databases? So here's some key technologies that will help supercharge your database performance. We have FPGA accelerators. We have the rENIAC data engine, which Prasanna will talk to you a little bit more about. NVMe SSDs, Intel Optane. Some of these technologies have been around for a while. Others are fairly new. But by combining these server technologies, we can radically accelerate database performance. So FPGAs, the first on the list. FPGAs are field programmable gate arrays that can be reprogrammed for different functions after it has been manufactured. So it's essentially an ASIC that has configurable logic that can be repurposed once you manufacture the ASIC as well as the board that you see in front of you. FPGAs have actually been around for quite some time. Started out kind of in the early 1980s, where they've continued to grow in performance and capabilities. Today, FPGAs have built-in artificial intelligence engines, high-speed transceivers, and various hardened IP blocks to more efficiently and carry out workloads as well as keep up with the performance demand that the customers are looking for. These FPGAs have applications in many markets: consumer electronics, scientific equipment, medical devices, in defense, in automobiles, and recently they've been starting to gain some traction in the data center. FPGAs are reprogrammable. For example, this FPGA accelerator card can function as an artificial intelligence accelerator 1 minute, then be reprogrammed to run as a database accelerator the next minute. Our partner Intel offers a line of programmable accelerator cards, such as the Aria 10 GX FPGA-based card that can be programmed to offload the CPU and accelerate various workloads. The key benefits of these FPGA accelerators are really in their flexibility to adapt to these different workloads and reprogrammability. Another benefit is that they can perform massively parallel computations that you don't find in a lot of different architectures. At Dell, we've worked very closely with Intel to add programmable acceleration cards to PowerEdge and are continuing to evaluate other Intel PAC offerings as we move forward. Now, Prasanna will talk to you a little bit more about the rENIAC data acceleration software. Prasanna?
Thank you, Doug. So Doug just talked about the immense benefits of the FPGA chip and how Intel has packaged these FPGA chips into PCIe cards as Intel PAC cards and working with Dell. One of the important elements here is, as a silicon architecture or a chip architecture, FPGAs offer immense parallelism. To tap into that parallelism, you need a software that actually complements that, and that's where rENIAC comes into picture. As Doug mentioned, FPGAs can be programmed to become a database accelerator or an AI accelerator. What we're going to talk about here is how we can actually supercharge the database clusters with the FPGAs that are offered via Dell from Intel on these PAC cards using the rENIAC's data acceleration software. Fundamentally, this is a parallelized data flow software that supercharges your existing database clusters. Today, later in some of the few slides, we will give you performance proof points for accelerating a database such as Cassandra. The data engine and data acceleration software from rENIAC is architected for pretty much any of the open source databases that are available out there, such as MySQL, MariaDB, RocksDB, and we will start with showing some performance proof points for Cassandra here today. Okay. When you combine the data engine, which is the data acceleration software from rENIAC, running on a Dell server for your and that Dell server has the Intel PAC card plugged into it. The one obvious question is, what type of performance benefits can we see? How hard is this to tap into this performance benefit? We want to be able to show you a proof point here as a starting point. One of the things that we have done working with Dell, as well as working with VMware, is benchmark these things. And one of the benchmarks that you're seeing here as a starting point is the throughput of the database goes immensely higher when the data engine from rENIAC operates on these FPGAs in Dell servers. You might ask, what is the benefit of this throughput? The hardest challenge that the database architects, one of the hardest challenge the database architects are facing today is scaling data. What does scaling data mean? Imagine that you have an online e-commerce business and your holiday season is coming. The traffic on these websites are going to go higher. The product catalogs, as an example, is stored in a database such as Cassandra. And every time you search, let's say HomeDepot.com or BestBuy.com or Lowe's.com, as an example, the product catalogs, when it is stored in the database such as Cassandra, needs to be fetched as quickly as possible. And during the holiday season, the traffic goes immensely higher because a lot more people are buying gifts or looking to buy themselves. So when you have billions of, what used to be millions of transactions now going to billions of transactions as an example. That's the scale that we are talking about, where the end vendors have to support them, or scale that is scaling massively, and that is also scaling rapidly, which means, hey, I have to go from tens of millions to hundreds of millions. That's scaling rapidly, right? So when you want to scale this rapidly or massively, especially when you're running websites like this, if the end users are not getting the response fast enough, they're going to lose interest. That's the important aspect of customer experience here. And what we have enabled here by working with Dell and Intel is rENIAC data engine helps customers scale rapidly and massively because we can boost the throughput. As you can see in here, the order of magnitude increase in throughput. What other benefits can it provide to you is the database systems that are running these, database software, the load on the CPU also goes down because the FPGA-based data engine takes care of serving more and more data with minimal involvement of the CPUs, which means that you have reduction of load on the CPU system as the other benefits. And where we get a little bit more technical here, a little further, is modern databases such as Cassandra, RocksDB. These are all a class of database called LSM databases, and LSM database runs other background tasks such as compaction, and compactions are also getting faster because of how we are architecting the database engine. So tuning for maximum performance involves, one, boosting the throughput, which we talked about, so that the end customer experience can be a lot more pleasant and seamless when the traffic scales on the websites. Boosting for predictable latency, which we will talk about further, but it's a predictable latency that is going to ensure these inventory records in these databases can be fetched in a predictable latency manner, which means eyeballs can be engaged. And then all the background tasks that are running these things are as less intrusive as possible. And along the way, if we can boost the capacity of the databases, even better, right? These are all the parameters to tune for maximum performance. There are a couple of other technologies that that can be used here. Obviously, one technique to store the data in memory to boost for performance, but you're bound by what memory capacity you're going to run into. One option to overcome that particular limitation when you're serving, terabytes and, petabytes of data is start storing the data and also possibly caching the data using NVMe SSDs. This NVMe is a protocol. There is regular NVMe SSDs, and there is also Intel's Optane NVMe SSDs. And Intel's Optane NVMe SSDs provides you, significant reduction in latencies, which means that increased performance. So this is yet another technology in the toolbox of how to supercharge the databases. And the NVMEs are much higher capacity, SSDs are much higher capacity than the memory, and are, relatively less expensive than the DRAMs. Yeah, another technology along the same direction is what is called Intel's Optane persistent memory, which can be, when you run into limitations on the memory, the memories are 64, 128 gigabytes. Optane persistent memory takes it much higher. This is one more benefit here. And these are four, very different technologies. So as an end user, how can you benefit from this? And, it's really coming down to how do you put a reference architecture together such that you can tap into the benefits of this. And this is where one approach that we have taken here is work with Duck and work with Intel to put together a reference architecture. We'll be sharing the details of it, in a few slides from now. But the idea here is that to give you the options so that you as end customers, depending on the use case that you have on hand, pick the right technology to boost the performance of your database so that you can get more and you can massively scale with as minimal effort as possible. While now from these next few slides, we're going to transition into talking about, a specific benchmark of data engine that uses these components, and specifically the components of Dell server, Intel PAC card, and NVMe SSDs. And we have also qualified, data engine on Optane NVMe SSDs as well. Before we do that, we want to give you an example of the database that we are going to use to show the benchmarks of how we can boost the performance of the databases. And the database that we chose to talk about more today is Cassandra. If you are an iPhone user or if you are a Netflix user, as an example, indirectly you are already using Cassandra because Apple uses, Cassandra, Netflix uses Cassandra as an example. And as I mentioned, there are also other e-commerce websites that use Cassandra, to store their product catalogs, or there are companies that use Cassandra to store user profiles. When you think about how is this recommendation made to me, how does, companies like Netflix know about what my preferences are? They store these user profiles in Cassandra and fetch them in real time to customize the experience for you. A little bit of a background on Cassandra is Cassandra was originally, developed and conceived inside Facebook, and then it was made open source. And one of the most exciting things about Cassandra is that it's a fault-tolerant database which is highly available, and it scales and is suitable for scaling large sets of data sets. And that's one of the exciting things about Cassandra. And where we come into the picture is how can we boost the performance of Cassandra as the scale of data increases significantly, or transactions of fetching and accessing this data from Cassandra increases tremendously. And that is where the rENIAC data engine comes into picture on Dell servers fitted with Intel pack cards and NVMe SSDs, may be regular NVMe SSDs or Optane SSDs. So here's the reference architecture that I was talking to you about. We have worked hand in hand and closely with Dell and also with VMware, so that we have benchmarked the rENIAC data engine. And the server architecture that we used here is the R70 servers, PowerEdge, Dell EMC PowerEdge R740 servers, 740 servers. And it has an Intel RER10 GX FPGA card. These FPGA cards are PCIe cards, very similar to how SSD cards come in the PCIe form factors, as well as an example. And of course, we have to connect these systems together because these are distributed data systems. So we used a power switch, and we ran these architecture both in a bare metal environment as well as in a virtualized environment. And so we demonstrated this ability to run inside a vSphere from VMware as well as in a bare metal settings. So this is the reference architecture that we have found as an example to show the power of maximizing for performance. So does this provide performance? Do we have measured numbers? And here is what we can show you as measured numbers by using this reference architecture. As an example, the throughput significantly boosts, an order of magnitude higher transactions per second when you use this rENIAC data engine with this Dell R740 servers with Intel RER10 FPGA cards along with NVMe SSDs. So an order of magnitude boost of throughput, transactions per second, is a metric that is used to measure that. Latency reduction, significant latency reduction of up to 18x. And why does latency reduction matter? If millions and millions of people, as an example, are watching and loading up and looking for a product on a website, if the website is not bringing the results of your product or giving you the details of the product that you're looking for, it's human psychology. We lose patience and we lose interest. The better predictable latency a database can deliver, higher the user experience, which means that when you search for it and when millions of people like you are searching for it concurrently, they all can see the results without waiting for the product backlog information to be loaded, as an example. So predictable latency is super important for a good online customer experience, and predictable latency at scale is super important for companies which are using these database technologies to serve the content. So 18x, you will see P95 is 95th percentile of times we're able to actually get you predictable low latency. So that's our significant boost in the latency that directly impacts end customer experience. And last but not the least, there is also reduction in number of load on the end CPU systems that are running these databases. When the end CPU systems are less in load, they perform much better, and they can perform other tasks as well. And what we have measured is up to 5x lower load, which means 5x. One way of looking at it is how can you actually put more workload in when you actually have less load from the database systems. These are some of the results from using a reference architecture that I was actually stating in the previous slide, which is rENIAC data engine, PowerEdge servers, Intel pack cards having ARIA 10 FPGAs, and of course using a switch, both in a virtualized environment and bare metal environment. VMware, for example, published a blog, summer of this year. If you search for rENIAC VMware Dell EMC blog, Cassandra, you should be able to get a link to that blog. There's also a white paper from Dell and white paper that we'll be talking about at the end of this particular presentation as well. So we have talked to you about tapping into the reference architecture, talk to you about tapping into the ability to use FPGA acceleration with a data engine on Dell servers. Is this something, if you are interested, you might wonder what would you want to do or how you would go about actually trying these. And this is where I want to be able to talk to you about how you can test this reference architecture. And Doug, you want to talk more about the accelerator lab that you have set up, that we have used to test these technologies, and we are also onboarding customers there. Doug?
Yeah, sure. Thanks, Prasanna. Yeah, in the Austin Design Center for Dell, we actually have an accelerator lab that we use to leverage to evaluate accelerator workloads, kind of evaluate the various accelerators, including the Intel pack FPGA card, and of course we try to stand up complete solutions such as with rENIAC, and we're actually very proud to announce that we had the complete rENIAC reference architecture running in the Dell Accelerator Lab today. As Prasanna showed, this is the multi-node Power server setup running with multiple Intel PAC FPGA cards and the rENIAC data engine. And that particular setup was used to produce the benchmark results that Prasanna showed in the previous slides. So we're really excited about that. We've also already used that particular setup to engage with a number of end customers who are evaluating this reference architecture and ultimately just seeing for themselves, you know, what it's like to kind of test drive this setup and seeing for themselves what the performance gains are when running Cassandra on this particular setup with rENIAC. And so if you're interested, we'd be happy to talk to you. Prasanna and I would love to dive deep down into some of the technical details of the rENIAC solution running on Dell and Intel. We'd be happy to start that conversation. So there are a number of services and support options aside from the traditional award-winning support that Dell Technologies is known for. And here's just a synopsis of the consulting and assessment services. And no matter where you are in your journey, we're ultimately here to help. To kind of close up, you know, if you have any more questions, if you want to learn more about the Dell FPGA acceleration, accelerator lab, the rENIAC solution, you know, feel free to reach out to your you know, Dell Technologies sales rep, who can reach out to us, or you know, feel free to reach out directly to Prasanna or myself if you'd like to get a little bit more in depth to this complete solution. If you want to kind of take a look and see a demo of our setup, or if you want to test drive it. You want to kick off a POC in the Dell labs or in your own labs. We'd be happy to, you know, have that conversation as well. So that kind of concludes our presentation. So thank you for listening. I'd be happy to take any more questions if there are questions, Peggy.
Well, thank you, Duck and Prasanna. We really appreciate all your words of wisdom. Now, before we begin with today's Q&A, please direct your attention to our webinar survey. It's available on the right of the presentation window. If you close the survey, you can reopen the widget by clicking the icon along the bottom of your screen. We thank you in advance for filling out the feedback form. Your participation in this survey allows allows us to better serve you. And now on to the question and answer portion of our event. As a reminder, to participate in the Q&A, just type your question into the text box, and it's located to the right of the presentation window, or click the Q&A icon at the bottom of your screen. If we're not able to answer all submitted questions during today's webinar, we'll be sure to share them with our speakers, who can reply to you offline. Okay, we've got quite a few questions. First question. I have a question regarding the FPGA cards. Excuse me. How do they integrate with the database server to speed up database performance? What is the fundamental process that helps reduce latency?
I can take that as a starting point, and Doug, if you have more to add, feel free to add them. So one question there is, if I heard it right, how do they integrate with the database server to speed up database performance, right?
Yeah.
One, from a physical form factor, these are PCIe cards. Servers have a PCIe form factor, and slots. So this card plugs into the PCIe slot. That is how physically the card can be deployed into a server system. And the question, I think the author or the person who meant to ask is, what's the deployment and how does the data engine work hand in hand with this FPGA card in a database cluster setup? We support multiple deployment models. One is a cache. These data engine with FPGAs on Dell servers acts as a cache for a database, or it also acts as a proxy plus a cache, depending on a cache or a proxy plus a cache. Either it sits part of the database cluster or sits in front of the database cluster, one or the other. And that's to the question of how do we integrate the database server to speed up the database performance. So you deploy it as a cache, or you deploy it as a proxy plus a cache. What is a fundamental process that helps reduce latency? FPGAs are, highly parallelized chip. You exploit the capabilities of the FPGAs versus a CPU is a general purpose, chip that can run general purpose. So essentially the data engine has a data flow architecture that's mapped to the FPGAs. So your ability to go access the data from an NVMe SSD considerably is reduced when you involve data engine on an FPGA. And when you are accessing the data stored in the cache associated with the data engine, you are not even involving the CPU as an example. So by reducing the involvement of the CPU or by speeding up a data path to go fetch the data, you are able to get significant reduction in the latency. That's the answer, Peggy. Doc, do you have anything else to add, or should we go on to the next question?
No, I think you hit that one pretty well. I think for different applications, there's other considerations to help reduce latency, but specifically for database performance, with the rENIAC setup, it's definitely using your proxies and using the cache to serve the data.
Okay. Here we go. Here's the next. On slide 14, the performance comparison of 5x reduced CPU load, 10x transaction throughput, etc. What is the cost increase? 2 times, 5 times, or 10 times?
That's an excellent question. At the end of the day, I think what we have seen is that it's the opposite. You end up with a lower cost of ownership. The reason that you end up with lower cost of ownership versus a cost increase is when you're able to perform more out of your database cluster because of the drop-in accelerator, you are able to serve more transactions compared to if you are going down the path of, the existing path of adding more servers to it. So overall, you get more out of an existing cluster, and in the process, there is a significant reduction in total cost of ownership. You have seen as low as 30%, as high as 70-75%. Yep.
Okay. Doc, do you want to add anything, or should we move to the next question?
I think we can move to the next question.
Okay, great. Okay. Here we go. What knowledge of FPGA-like VHDL programming is also required?
So I could take that one, Prasanna. So
go ahead, Doc.
In general, if you're standing up your own FPGA-based accelerated solution, you will have to have some knowledge of FPGA design, VHDL programming or Verilog or any other hardware programming language. You'll also have to have some knowledge of FPGA implementation to build the bit streams. You'll also have to understand the drivers, the APIs, and build your complete solution around that. What rENIAC offers, and working closely with an ISV, is that they do the heavy lifting for you. They build the bit stream, and they build their drivers and the whole software solution whole stack. So ultimately, it's, you drop this in, and with some minor adjustments, everything just works, and everything performs better. Anything you want to add, Prasanna?
No, if they're setting up their own clusters, and they are trying to do it by themselves, they would need to know the HDL programming, and that's where the data engine comes into picture. If you're using the data engine, you should not even know what's inside the FPGAs. You should be able to tap into the benefits by using the software that we provide to run on these FPGAs and CPUs. So VHDL programming knowledge is not required or not necessary when you're using, data engine from rENIAC.
Okay. Let me see. Excuse me. This question, whether FPGAs other than Intel, like Xilinx, are also supported. So are other FPGAs supported?
Yeah, I could take that one as well. So that question can be answered kind of twofold. One is from a Dell EMC perspective. We do support other FPGAs other than Intel, and we do support Xilinx, specifically the Alveo U200 is supported. And as I mentioned before, we continue to evaluate FPGA accelerator cards and other accelerator cards for that matter to see if there's a fit within PowerEdge. And we're continuously evaluating and figuring out where and when we intercept with those accelerators. The second part of that answer is from, I guess, Prasanna, maybe you could take that one. Is from a rENIAC perspective. Today you can run the rENIAC data engine on the Intel PAC card, but I'll let Prasanna talk about support for Xilinx.
Yep. Thank you, Doug. We also support Intel PAC cards, and the product is shipping on Intel PAC cards. We also support Xilinx architecture. Peggy?
Okay, terrific. Is the Dell lab the only way to test this, or can we test rENIAC, we use Dell servers already, in our own test lab? And if so, how?
So our Dell Accelerator Lab is probably one of the easier ways to test it, since we already have the entire setup running in our servers today. We would work closely with you to give you, the access and credentials to log in and test drive. But the other side of it, can you set up a PLC in your own labs? Yeah, absolutely. And maybe Prasanna, you could talk more about what steps we would take.
Absolutely. So you would require, we can use your existing servers, or bring up the reference architecture that we were proposing here, and you would be able to purchase these cards, and by working with Dell as well as with Intel and us, and you will be able to get the setup up and going on your own site, and we're happy to support that as well.
Okay, let me see. Here's another: support for ELK large node setup to reduce the number of data nodes. If that's a yes answer, by what ratio?
Thanks, Peggy. I suggest that we can take that question offline. Essentially, the person is asking for can we do ELK stack on for FPGA acceleration? We can take that offline on the roadmap to support that. Absolutely. And
okay,
what we have seen, or what we are essentially seeing as the benefits towards that. Yes.
Okay, got that.